Wow, look at that. All silence. Welcome back. How are we doing? All good? Enjoying? So, this afternoon, we're going to talk about the future of facades. What's expecting ahead of us? What challenges are we going to face? That's a really difficult conversation to be had because you don't know yet what you don't know. We may be talking about engineering solutions and material we haven't invented yet. So how are we going to get there? And I know that it may really sound quite far-fetched, but if I could turn back time 10 years, if I could have predicted what was going to happen in the following 10 years, I know perhaps I would have done something different. And that's where I want you to get with your minds. And we've got some phenomenal speakers to talk us through their ideas, their experiences on this topic on stage today. And I must say, I really feel very privileged because I happen to know all of them personally. The first speaker, actually 22 years ago, and this is a true story, when I got together with my partner, she said to me, "Oh God, I need to do a presentation on sustainability at the RIBA." And I thought, what's a presentation, number one, and what's sustainability, number two? And I genuinely learned about sustainability for my partner. Please don't tell her, those who know her, that I said that, because she's really going to kill me for saying that. But the key thing here is that Peter, our next speaker, works at Bennetts Associates, and she used to work at Bennetts Associates. So some of the practices that we're dealing with today, they have been talking about sustainability for over 20 years. And we kind of only jumped on the wagon, when? 3, 4, 5 years ago. Fair enough, now it's polarized the discussion, perhaps. But, you know, that's such an interesting point of view to think about what might be the next thing to think about. So please do give a round of applause to Peter, who's joining on stage now. And I'm going to read something about Peter. This is the third experience that we have together. We've been on a few panel discussions at various conferences. Peter joined Bennetts Associates in 2001, and he's a driving force behind the sustainability projects in the practice. I've got a list of 50,000 projects to read that he's done. I'm not going to read that. But he's currently responsible for Timber Square, a net zero carbon workplace development in Southwark. I went to see it last week. It's brilliant. Even if you can get a chance to wander around, it's a really different type of building approach. Peter has taught, lectured, and written widely on the subject of architecture and sustainability, was a design fellow at the Department of Architecture in Cambridge for 7 years, and chairs the Knowledge Quarter's Net Zero Carbon Advisory Group. Peter, thank you very much. Really looking forward to this. The floor is yours. Thank you.
Good afternoon. Talking about the future, I've already given away the first slide, actually. I was thinking, talking about the future, wait until you get the first slide. I was going to talk, really, to begin with, about the context of where we are and the problem that we have. So it's less about maybe the solutions going forwards, but rather how we've got where we are. And that, I think, often gives us some of the answers as to where we probably need to go. I was thinking of calling it "Is Curtain Walling Dead?" and I thought that might be a little bit too brave, and so I didn't. It's a changing face of the facade. But to start with, we'll go back to the Great Pyramid at Giza. There's been some very interesting research on this recently, and I think this was the tallest building in the world for almost 4,000 years, and yet the amount of energy used to build it, the calorific energy, was less than a small contemporary office building in London requires. And yet it stood as the tallest building in the world for almost 4,000 years. And I think our world, our industry, as many people will have heard this morning, but also just the world that we inhabit seems to just get perpetually more complicated. And there's a brilliant book I read recently called The Edge, which is about resources. And that was about the only book on sustainability that I've read that simplified the subject rather than complicated it. And it managed to take almost all of the polycrises of climate change, biodiversity, war, hunger, etc., etc. And it distilled them all down to the essence of the problem being the way that we, how profligate we are with resources. And so if we begin to think of things maybe in less detail, but just with an overriding attitude of doing much more with far less, and that will get us a long way along the route. And so that takes me to the second slide, which is really, this is just intended as a way of saying there are things such as zero carbon or circularity, words of that ilk that are bandied around, and they seem like new things. And yet, if we look at the whole of human history, from the pyramids onwards, really the whole of human history until about 250 years ago was basically zero carbon. It's only really, once you get to the rebuilding of London, the incredibly heavy use of bricks thereafter, that we begin to enter the carbon age. And we have accelerated hugely over the last 50 years the amount of carbon that we as a species are producing and emitting into the environment. And we also know that we will probably, and I'm pretty confident it will happen. I'm not one of the pessimists about it. We will get to a point very, very soon that we're in a post-carbon age. And it is from today, the next couple of decades, and the previous 200 years or so that will be the aberration. That's the unusual bit. The whole of the rest of our future will be zero carbon, and the vast majority of our past is zero carbon. That's where we are, without question, headed. But how do we get there on facades, or how have we got where we are now? This is a photograph I use a lot in talks. I think it's the most significant building of the 20th century. Most people haven't a clue what it is. It's called the Millen Building in San Antonio, Texas, built in 1928. Its significance is that it's the first building in the world that has air conditioning in it. The first building for human habitation. It was developed in the meatpacking industry in Chicago in the late 19th century. This is the first building that has air conditioning in it. But as you'll see, it's quite a traditional building in many respects. It's got small windows, it's got heavy brick facades, it's got opening windows. The air conditioning is augmenting its environment. It's not doing it in exclusive an artificial environment. If the air conditioning in this building breaks down, the building is broadly still habitable. It's not quite as comfortable, but it's broadly habitable. Then you come to, and I will start with a caveat. I was in Berlin last week. I went to the National Gallery by Mies for, I don't know, about the 10th time. I am hugely into and adore Mies. This isn't a pop at Mies, albeit it might seem like it. I'm a massive Mies fan. There's 2 Mies buildings in this. But they record an interesting evolution for architecture, really. The first one is the Friedrichstrasse competition from 1928 in Berlin. Mies didn't win. That wasn't built. It couldn't have been built. The structure existed, the cladding existed, the lifting technology existed. But in pre-Second World War, relatively poor Europe, the mechanical systems didn't exist for that building to be inhabitable. It could have been constructed, but it could not have been inhabited. Then the Second World War happens. There's massive technological explosion. Mies moves to America, which by then is much, much wealthier and more technologically advanced than Europe. And in the middle, 1958, you get the Seagram building in New York. And there, basically, the Friedrichstrasse building is built. It's an all-glass facade. The building is the same on all of its orientations. And in effect, the architecture is being liberated from the need to temper climate. And that would have been hugely exciting at that point. And I know for a fact that I would have been as wrapped up as anybody within that myself, had I been an architect in 1950s America. It's huge, it's just liberating for architecture. The consequence of that, though, is that a lot of architects like me, they have been classically trained. And by the time you get into the second or the third generation of modernism, that knowledge has completely vanished. And we end up then, and it could be myriad of buildings that I chose for this one, but we end up with the Portland, Oregon building by Michael Graves. And at this point, the architecture is literally about that thick. It is super graphics on a facade. It plays no role in the tempering of the internal climate. Architecture has completely lost its ability to deal with climate. And that's part of the problem that we're in right now. And it brings you onto places like this, which are completely rootless culturally, hell on earth in many ways, and there's no connection to its environment. And in some respects, these are the type of buildings that they're perfume bottle architecture. They're the same all over the world, massive glass facades, doesn't matter where you are, everything is the same. There is a massive climatic issue with that, but there is a cultural issue with it as well, that is a completely rootless world. And we can learn huge amounts from the way that vernacular architecture deals with both its ambient climate, but also the available resources that are there. How does it deal with both the need to provide shelter, but also to temper its ambient climate? We'll slightly gloss over the fact one of the mud houses has collapsed on the bottom right. But whether it's mud houses in Yemen, with extraordinarily large diurnal swings, very heavy use of materials to compensate for those swings, or it's Malaysian longhouses where it's incredibly humid, very static environment. They're dealing with it in very, very different ways. And there are many, many things we can learn from that. Then I'll forward to, this is part of my education. These are something called the LT, lighting and thermal curves, that were developed in Cambridge by a physicist in the 90s called Nick Baker, who's one of my tutors. And at the time, what Nick was trying to do was find a very simple way. These were all Excel-based and very, very simple models behind it. But he was trying to produce a series of graphs where you could very easily see, dependent on orientation, internal use, and location in the world, what the best balance of heating, cooling, lighting for glazing ratios was. And as an architecture student, I was incredibly excited by that. I love this idea that through response to climate, manipulated facades and buildings, and they changed as you moved or what you did inside. And we ran a whole series of parametric studies using Nick's Excel spreadsheet. And the slightly disappointing result that came out of that was that the ideal glazing ratio was almost always somewhere between 30 and 50%, irrespective of where in the world you were, irrespective of which orientation you were facing, and irrespective of what you were doing inside. And for a committed modernist, that was hugely disappointing because it's basically a Georgian house. So Quinlan Terry was right, and that's the end of the lecture. That is slightly disappointing place to end up. Stone facades, smallish windows, and very, very eloquent facades. So actually, the dissertation that I'd started doing, looking at how we could manipulate facades, actually ended up being, well, if the technical answer is so obvious, why are we not doing it? And so it morphed actually from being a technical essay to being one that was really a cultural history about why are we not doing this. And then, of course, we moved to today, and increasingly we're facing that rather complex balance between operational and upfront carbon. And what this is showing is the dotted red line is the cumulative operational carbon emissions from a very typical office building from about 5 or 10 years ago. And then the pink is just upfront carbon from that building, day one. And as you will see, they hardly ever meet. And in fact, grid decarbonisation is happening much quicker than we think we're expecting. So those lines will never, ever, ever meet. That vastly more carbon has been emitted by a building before anybody ever inhabits it than will be emitted for the whole of the rest of its life. That alters the equation, whereas we were focused very much on operational carbon for quite a few years. That changes the balance dramatically, and that has a big influence on facades in particular. Now, there are probably two primary ways that we can begin to address that, and I'm talking about buildings across the board. The first of those is simply reusing, continuing to use the buildings that we already have, and you'll have heard those stats that 80% of the buildings that we'll inhabit in 2050 already exist in cities like London. And we're seeing this more and more. Much, much more. Almost 40% of our workload now is, by area, is the reuse of buildings. If you can't reuse buildings, then the next best thing is to begin looking at much lower carbon materials, and especially biogenic materials, principally, but not solely limited to timber. And there are interesting parallels, I think, with a number of different industries and elements of buildings around where we've come from with timber as a structural material. And I think when we first started looking at CLT in about 2008, it seemed weird and wacky and hairy, and if you'd said at the time we'll be doing massive commercial schemes using CLT that were, was referred to Timber Square earlier, I wouldn't have thought we'd ever get there. These were all small projects, but we have, now, pushing 40% of our workload as well is timber in some way, shape or form. And here we have Timber Square, which is on site at the moment, and a full timber project in Brent Cross that we're working on. We're probably there. There are complexities with full timber buildings, but that has become completely mainstream. So one thing that we try to do all the time is to keep our eyes on what are today's weird, wacky, and unfeasible materials, because some of those will end up being mainstream solutions relatively quickly. Now, these are mostly on relatively small buildings at the moment, but they're all things that we're looking at. And I'll come on in a little bit more detail with stone in a tick, but load-bearing stone, we've actually completed a few buildings now that are using modularized straw. And of course, the beauty of straw is that whereas with timber, the growth cycle is anywhere from 20 to maybe 60 years, with straw, that carbon has been sequestered within the last agricultural year. And I think you can genuinely count the sequestered carbon as part of the base, the initial design with straw. I think that's going to get much bigger. We've more than enough straw in the UK to build something like 500,000 houses a year using it. And the other one that we have been looking at, both in back of house places and also in facades, is rammed earth. And there are some evolutions in modularized rammed earth in Switzerland that are very interesting. So if you move on to facades, clearly, over the last few years, our emphasis, the emphasis of our work, has been on sub and superstructure. That's 50% usually of upfront carbon. Naturally, our emphasis has been there. But we do know the facade is quite a lot. It's probably about somewhere between 11 and 15% on average. And it's quite a significant piece. So increasingly, we're looking at that. And if you just do some very simple arithmetic to try and set a target, we get a Letty target probably of somewhere around 350 kilograms per meter squared gross area for the building. We know that the general facade to floor area is somewhere around 3, and so that gives us a magic number of somewhere well under 150 kilograms of CO2 per meter squared of facade area. That's got to be our target, probably pushing somewhere down towards 100, really, for us to have a realistic chance of hitting that overall building number of 350. And so some of the evolutions that we're looking at, and some of this is very interesting, and it's looking at timber unitized curtain walling. It's not something we've actually done on a project yet, but we've done quite a bit of looking at that with various cladding contractors, and I think that is becoming more and more feasible. There are some questions around it, cost and fire, but those are slowly being addressed, and we think we can probably reduce the overall upfront carbon by maybe a quarter on something like that. But that sort of brings me on to the last few slides of this, which is one potential solution that we're quite interested in at the moment. And this isn't saying this is the solitary solution, I don't think it is, but something that we've been interested in for a long time has been stone. We've done quite a lot of stone buildings, but it's usually been stone as a cladding. It's not stone as a load-bearing material. But the interest there is, of course, that stone is very rooted in where it's from. I mean, a stone building in southwest England looks radically different to a stone building in Yorkshire, or the west coast of Scotland, because the material is literally beneath your feet and it changes. So that's one excitement about it, but its carbon is also, as long as you don't do too much to it and you don't transport it too far, it's a relatively low carbon material. So there's a piece of work that we're doing at the moment that we're looking at research. And these are, I wouldn't wholly trust the numbers, but I would trust the proportions on these. There's a lot of detail to go through those, but it's as beginning to look at what are the comparative benefits of a curtain walling system moving to more solid, 50% solid, using stone on a precast concrete backing. I mean, that is a very familiar technology. Then looking at, can we use something similar but begin removing elements of structure? And finally, looking at full load-bearing structural stone as part of the wall of a building. And you can reduce the carbon emissions pretty sharply through that. We're fairly confident you can get, in fact, probably below some of those numbers. And it comes onto one of the benefits, which is that inevitable problem that we have on every project is time v cost v carbon. But if we can just use less stuff, that's less cost and it's less carbon. Now, one thing that has been coming up recently on a number of projects is when you begin looking at the facade and you're trying to balance cost and carbon and put more solid on the wall, aluminium's not the place to start, but looking at handset brickwork comes out very, very well. Metsec behind it, handset brickwork done in lime, it comes out very well on cost and on carbon. But I have to say, it just doesn't feel like the future to me. I mean, sending increasingly middle-aged blokes up the outside of buildings to lay small format things on top of one another in all forms of inclement weather. We are a quarter of the way through the 21st century. That doesn't feel like where we should be going. So you can prefabricate it, of course you can. But, cost is good, time is good, carbon goes through the roof. Which leads us to, augmented stone. And there, I think there is something very interesting in that it can be prefabricated. It goes down a modern methods of construction route. We can prefabricate entire stories of it, and the carbon is very low. So this is something we're looking at on a few projects at the moment. And of course, we found on timber, always having a plan B is the best way of moving forward. You've got to have a route that you can back out. I mean, that's somewhat conflicting with some of the things this morning about building safety acts and always having everything set out, several projects in advance. But being able to twin track an approach often helps you keep the one that you're trying to keep going. The plan A keeps going if there is a conventional plan B. So this is some stuff we've been looking at. This is 40 Chancery Lane, which we did a few years ago, and the details for that. It looks like a stone building. It's actually a precast concrete building. And if we can simply replace, nothing about it geometrically changes, but if we can just replace 50% of that with mass stone, we can get a huge long way towards much, much lower carbon buildings. And so the penultimate slide is then just one building that we're working on at the moment. It's in the city. We've got our carbon targets. It's a reuse of a big concrete frame, and we're putting a timber wrap around that and then using limestone around the edge as the load-bearing structure. And provided we can hit all of the carbon and the cost targets, it's in the city, so the cost targets are actually very high, then we can get to a much lower carbon building that is almost entirely dry in its construction. So it's a load-bearing stone facade, and it's a full timber new structure. And so that leads me to the final slide, which is a vision of the future, which is a Georgian house in Edinburgh that has a structural stone load-bearing facade with an entirely timber interior. So that may well be both the past and the future. Thank you very much.
Peter, thank you. First of all, obviously, your topic has been, and presentation and content has been highly appreciated. This is a really interesting topic because do we need to go backwards then to go forward? And we seem to have lost common sense here in terms of using and reusing materials. We need to go back perhaps to in those days you didn't throw away anything. And the reason why you didn't throw away anything is because you didn't have anything. So anything that you had, you would use it, reuse it, and so on. It's not just about Georgian houses. We have churches and castles in Europe which are built from tombstones, from pieces of other building. They may not look particularly well, they're a bit patchy, but they've been there for thousands, hundreds of years. Yeah. How do we get back to that? The pyramids have been there for 4,000 years, so in a way...
I think there is...
What do we need to change?
Probably just our mindset, in a way, that we've got to a point where it's often just cheaper to chuck something away than to reuse it. And there's a deftness to reusing stuff. And there was definitely a generation before that was much more alive to not wasting things. I mean, my grandma used to always say, waste is wicked, which at the time I thought was a religious thing. It turned out she was from Yorkshire. Yeah. She was just tight. And we've probably got, we've fallen out of that mindset. And there is a building which I haven't used in this, but one that we did in Cambridge, which is, half of it is the reuse of 3 listed buildings in central Cambridge, and half of it is new build. And a lot of as you go around the listed buildings, quite a lot of the windows and the doors are older than the building. And you realize that those have been demounted and then reconfigured, and the doorways have moved. And we were, at the time, and this is a project from 15 years ago, we were compelled by the planners to dismantle and reassemble part of the facade, which at the time, I must say, I did with some discomfort. But now I look back on it, and I think actually that was the right thing to do. That has been going on for the whole of history. And we need to start reusing things. Also, I mean, from the facade industry, or the outside of buildings bit of the industry, right now, on average, we spend something like 30 to 35% of the budget of a building is spent on hidden mechanical systems that are largely making up for the failure of architecture to deal with climate. The stuff on the outside of the building that stops you falling out and historically has regulated the climate, we spend something like 8%. I mean, there's just a huge imbalance there. And the mechanical systems, usually we throw away after 15 years and replace them because they don't work anymore. So there's something insane in that. We should be spending twice as much on facades and half as much on mechanical systems. That's nirvana, where I'm kind of head. Yeah. I thought the suggested curtain walling title might have not gone down well, but that obviously went down exceptionally well.
Do you think things are changing for clients? Are they supporting your ideas? Are they buying into it? Or is it the architect's fault to say we want flashy buildings and stuff? Are you changing what?
I think
what do you think? Are clients now telling you, I don't want to go back to that, but
no,
my new flashy building needs to be...
It's not going to look like that, but it's going to, in principle, be not that far away. And that's where the lessons from your first question, do we have to go backwards? Well, maybe not go backwards. We certainly have to be aware of where we've come from to know where we're going. And it's interesting, particularly in the commercial world, which always seems quite a strict world. It's quite a brutal world in many ways. But as long as you're getting the numbers to stack up, basically nobody cares. And in that sense, it can be quite liberating in that sense. So it's far less opinionated than the cultural sector that we do a lot of work in. And most developers don't want to do bad things and create horrible buildings. It's usually that numbers don't stack up how those things begin to happen. And if the numbers on cost and carbon are stacking up, that's going to happen. Okay. And that is partly resident on us as an industry to help them get there as well. And that's why, particularly this book, The Edge, by Jonathan Maxwell, was so influential on me this year, because of that idea. This is all about how we use resources. And if we can get our heads around that, and how do you just begin to do literally more with less? I mean, an inversion of Mises' famous quote, how can we do more while using less? And it used to be, if you are simply trying to replace in inverted commas, an unsustainable material with a sustainable one, it's usually more expensive. If you can just not use a material, it's both more sustainable and it's cheaper. So how can we just do more and more with less? And how can we just get buildings that last longer out of that?
Okay. Any question from the audience at all before?
Can't actually see the audience. But
I can. Oh, that's wow. Better. Yes, I can see the audience. Yeah, yes.
Oh, no, I preferred it, actually.
Any question? Yes, there's a question. I think we have a...
Who's first?
2 questions.
When you were showing the difference between the Plan A and Plan B design and the two side by side, one of the things I noticed was you've moved a lot of the thermal mass outside the building, and that's going to have a very significant effect on the way the M&E system, for instance, is required to operate. So there are some choices where you put the thermal mass will affect the way the comfort of the building behaves. And how do we use these buildings in a way that is much more like the low energy form that they were originally designed with, where people's demands weren't quite so high for that thermal comfort?
That's true, to an extent. I think our experience has been that thermal mass, particularly in commercial buildings, isn't quite as important as we thought it was a while ago. It's not to say it doesn't make a difference, it does, but it's not quite as significant. There's a whole piece of work sitting alongside this that I haven't covered, which is about trying to reduce MEP. This is the getting rid of that bit, which I'm desperate to do. And there's something very interesting in going down a much more decentralized route and a much more modular route that particular, as soon as you have opening windows that human beings have control over, they become inordinately more tolerant of their environment. And in actual fact, Nick Baker, the physicist I referred to in Cambridge, there was a whole series of experiments done in the 90s with him where you could measurably prove that individuals, if they were given control of their environment, they make it measurably worse, but they feel more comfortable. And so if somebody is wrong but thinks they're right, ergo they're right. And if they think their environment got better but it measurably didn't, well, it did get better. And we can alter that, that close control that we've had in the city, which is like, 22 degrees plus or minus 1 or 2, that's got to go. But that can go if you've got opening windows. And then it fluctuates enormously. And actually one of them is just having more sensible clothes. My wife's a lawyer, and they do not wear sensible clothes. It's the same woolen business suit all through the year, and it's got to change a little. And that is changing, I think.
Okay. We've got time just for another quick question. There was a gentleman there.
Yeah, this is probably a stupid question.
Good.
But with regard to timber, which I love, and post-Grenfell fire risk, how do you manage to increase timber use, especially in facades, and avoid it crashing and burning, to use a...
Well, one thing I say, Grenfell was a concrete building wrapped in plastic. Timber wasn't the problem there. One of the issues, a project I haven't spoken about, which was mentioned, is Timber Square, which is at its maximum about 16 stories hybrid timber structure. That has been subject to so much scrutiny as a result of being timber. And I would bet my bottom dollar it is far safer than a conventional building, because there are details that you see on conventional buildings that are not done properly, that have never been considered, that are worse than the ones done on timber buildings. The risk is, I think, the thing that worries me is when an industry, I suppose, first starts with something innovative, you probably get the people who are really interested in it and do it, well. The danger comes with the second wave, where it becomes less thinking. And we need to get very quickly to generic details that work. And by and large, we probably, irrespective of whether it's an organic material or an inorganic one, we just need to build better. Buildings have been appallingly built in Britain for a very, very long time. I worked in Germany for a number of years before I'd ever worked in Britain. And I was shocked when I came back to Britain about how shoddy the buildings were, yet simultaneously very expensive. So they're overcomplicated. I think a route is simplification.
Simplification,
much
change of materials, and build better. Mm-hmm. Peter, thank you very much. But you're going to hang around for some drinks, or maybe our audience will talk to you later as well.
Thank you very much.
Great, thank you. Ron, thank you.